So the operations we most care about with scientific notation, the things that come up all the time in the sciences, would be unit conversions, where we're either multiplying or dividing by numbers in scientific notation. So let's go ahead and see an example. So I had one up that I'm going to steal. If we had something like this. So how many atoms are in a pure gold necklace that weighs 25 grams? Now, this is well beyond what we'll do in this class, but I just wanted you to see what the overall application of this is. And that's, like I said, chemistry, physics, astronomy, all those situations where you have really big or really small numbers. So this is a standard unit conversion or stoichiometry problem you'd see in a chemistry class. We know something. We know that we have 25 grams of gold, right? And we want to know how many atoms we have. So we have some conversions to do. We got to get all the way from grams to atoms. Now, there are two different values that we're going to have to use. One is the atomic weight of gold. This is something you find in your periodic table. So there's 197 grams of gold for every 1 mole of gold. So still we haven't used any scientific notation, right? The scientific notation comes in with that atoms per mole that we talked about in the first video. So for every 1 mole of any element, there are 6.02 times 10 to the 23rd atoms. This is what allows us to put numbers that are a heck of a lot easier to write on our periodic table, because if we wrote something like this on our periodic table, it would be crazy, right? So this is standard for every different element, and then this changes on the periodic table. So as you can see with our unit conversion here, grams will cancel, moles will cancel, and we're just going to be left with atoms. So in order to actually do this math, we're going to take and multiply 25 times 6.02, divide that by 197, right? So we're going to take all of these numbers, and this is all going to be times 10 to the 23rd. So I'm going to bust out a calculator. Oops, that's not right. You got to type things in correctly, otherwise the calculator doesn't work. So here's what I got out from this. 0.764. I'll round to 3 decimal places, or 3 significant figures if you're thinking chemistry. I have no reason for using 3 sig figs, so just know that. In fact, I should probably be using 2 because of the 25 grams, but it's a math class, so I'm not going to talk to you about significant figures. Here is the situation I was talking about, why it matters so much whether or not this is in scientific notation. This is not in scientific notation because the number in front of the decimal place is 0. And remember, we said that number has to be non-zero. It's got to be 1, 2, 3. It's got to be a number, 1 digit. So we're in trouble here. So we need to go ahead and have our decimal place there. We know our answer needs to be 7.64 times 10 to the something. And now here's where I look again at that big versus small. Before I had this decimal here, is this number bigger than 1 or smaller than 1? This is a small number, right? Which would mean we need a negative exponent. And we only need to move over 1, so we need a negative 1. So we're going to add that negative 1 into our 23 to get our new exponent of 22. Like I said in class, the other option here is to start writing out what 23 would look like, and then think about how much you would need to come back to the correct decimal spot. So we need 1 less to come back to that correct decimal spot. So that gives you an idea of how this is actually used, and then also the tricky types of multiplication division questions where you end up needing to do a little adjustment because you didn't end up with something that worked out pretty. So I'll do 2 more, 1 multiplication, 1 division, and then I'll let you try 2 without all of the crazy science, so it's a lot easier. This is more like what you'll see on a test, so something like this. 3.2 times 10 to the, let's do positive 20 times, we'll do 6.1 times 10 to the negative 15. So we're going to deal with these just like our 10 to the powers were actually x to the power. So I'm just going to quickly write beside this. This is like if we had 3x to the 20 times 6x to the negative 15. right? We would go ahead, if this was the problem, we'd multiply our coefficients because we'd realize these parentheses, all this is just multiplication, right? And multiplication, the order doesn't matter. We have that associative property and the commutative property, which let us basically flip these two. So this is just, oops, I forgot a negative. And then we can deal with these numbers, or those two factors and those two factors. So 3 times 6 is 18. Ooh, that's not what I wanted. And then when we have two things, same base, right? Two factors, same base, different exponents, we will add their exponents together. And remember, this is one of those things on test, if you weren't sure, make yourself a quick little example. Okay, this is x, 3 x's, right? That's what that means. And this is 2 x's. Okay, yeah, that's going to be 5 x's. So I just add the two together. There's lots of ways to show this to yourself by simply just writing things out, just like we did in that one worksheet where we discovered all those exponent rules. Don't memorize them. Prove it to yourself that what you're doing is correct. So in this case, we need to add 20 and negative 15, which we will do carefully and get a positive 5. So same business is going to happen over here, except for I have a 3.2 and a 6.1, so I got to bust out a calculator. So we have a 19.52, and we got times 10 to the 5th, just like on the other one. We're going to add those two exponents together. Now, this is the exact same issue we had in the last problem, right? We have two numbers in front of our decimal when we should only have one non-digit number. So we need our decimal place to be there. But again, looking back at our original problem, we go, is this a big number or a small number compared to 1? And this is big, right? So if I want to move this over, I need a positive 1 exponent. So our new number is going to be 1.952 times 10 to the 6th. And again, since this number is smaller, it wouldn't have been so bad. 1, 2, 3, 4, 5. If I want to go all the way to here, I'm going to have to go back all those 5 and then do one more for 6. So that's another way I could get to that 10 to the 6th. So multiplication, multiply the numeric portion, multiply your A's, and then add your exponents just like you would if we were dealing with variables, right? Division, same business, right? I don't know. Use the same one. 6.1 times 10 to the 20th divided by 3.2 times 10 to the negative 15th. Now this is the one that you guys got in trouble with on the little pieces of paper that we were doing on Thursday, our little review. So same idea. If this were 6x to the 20th all over 3x to the negative 15th, we would deal with the numeric portion because this is all the same thing as 6 over 3 times x over 20, x to the negative 15. So we deal with that first, simplify those. So in my calculator, I'm going to do 6.1 divided by 3.2. So I get 1.91. I'm going to just keep 3 decimals, or 2 decimals. There's no rhyme or reason for this. On the test, I think I chose things that worked out a little more evenly. And then, remember, usually here what we would do is we would subtract the exponents. So this one will be 2x to the 20 minus negative 15. This is where everybody had their mistakes on that little worksheet. We all forgot to subtract the negative, so I had a lot of 5s. I had a lot of students give me negative numbers. If you want, you could also think, remember, this flips up and becomes 10 to the 15. Then you can add the 2, however you want to do it. But in this case, you should end up with 10 to the 30, oops, left off my 10, times 10 to the 35. Because 20 minus a negative 15 is 35. So in this one, we do only have one number in front of the decimal, so we are good. That's our final answer. So I gave you a bunch of these to practice in the sample problems by type, and there's also a ton of them to practice in the sample exam. So as you go through those, if this is something you had any trouble with, you can use those to test. I'm also going to post a video of how to do this in your calculator next. So if you want to see how to type this into a calculator, especially that 36X Pro that I've told everyone to buy, you're going to get that one next.